Okay, so hello and welcome everyone to the MachineKit Meetup 2017. Today I will start with the talk about the current status of Machinetalk. First, I'm going to give a quick introduction to Machinetalk. If you are not already familiar with Machinetalk, I think it's still a good refresher after having seen a lot of Machinetalk. Then I will explain how Machinetalk is currently used inside MachineKit. Then I will continue with my latest work on the Machinetalk GSL things. So you might have seen that on GitHub and maybe a little bit on the mailing list as well. Then I will talk about the work on Machinetalk generic. And last but not least, I will talk about the current status of Pi Machinetalk. So what is Machinetalk? In short, Machinetalk is a middleware that works as layer between applications or services. And it's intended to be used for communication between components of a software application. And in case of Machinetalk, also for communication between real-time and userland HEL components, for example. And at the same time, it should be also used to allow communication between local and remote components. So in general, it should work as a layer that makes connecting and creating distributed applications easier. The first use case for Machinetalk is like maybe multiple user interfaces connected to a single computer. So in this case, we have also like a distributed setup, and our user interface can be located on a local computer or maybe a remote computer. Another use case is maybe like a workstation connecting to multiple machines. So one machine is controlling multiple, like one computer is controlling multiple machines. And in general, Machinetalk is designed to be used inside MachineKit, like not only for communication between, for example, user interface and MachineKit, but also for internal communication between the Machinetalk components. Machinetalk, yeah, oftentimes that's one thing which we started with was like Machinetalk being just a combination of SeriumQ, Protobuf, and DNS-SD over multicast DNS, which are like free standard or de facto standard technologies. But we will find out a little bit later that Machinetalk also is a little bit more. Actually, it adds an additional value to these technologies. So it's not like these free technologies just thrown together. It's like adds on top of it also like protocols, a way to describe components, and it works with services. And the whole idea is to abstract the operating system and platform technology in general. Like, for example, the idea is that you don't use, let's say, Unix sockets or something this directly, but instead use SeriumQ to abstract it, or you don't create your own messaging serialization standard, but instead use Protobuf, and for service discovery also use a standard which is DNS-SD over multicast DNS. And yeah, how is Machinetalk currently used in MachineKit? Some people already have asked that, and yeah, so this is like a quick overview how Machinetalk should be used in MachineKit. Well, like how what is the scope of the whole Machinetalk concept? So currently, it's already used for the remote user interfaces, namely Qt Quick VCP, and also the experimental web VCP. So here the Machinetalk would interact between like a component running on the real-time host. In this case, HalTalk is not a real-time application, but a userland application. And for example, a remote client could be a tablet, could be a normal computer, and can also be located on the same host. And also between, like this is currently not implemented, but this is also it. Like Machinetalk is designed to be used for that. Like maybe communication between the components of MachineKit that are running as userland threads, and also part of it, like since we have chosen Protobuf as serialization standard, we can also use Protobuf to communicate between real-time threads and real-time components of MachineKit and userland components. In this case, we would have to use the ring buffers. And yeah, this is only partially used right now. There are examples, but I don't think this has replaced like NML, for example. So currently we are at the point that Machinetalk, like HalTalk and the remote UI is working. There's an experimental web UI, and there are some other services for starting applications and so on. Yeah, these are the currently implemented Machinetalk services and components. Like HalTalk, for example, provides the hal-r command and hal-r comp service. Also HAL group, but yeah, HAL group is somewhat, let's say it's like not used a lot, and we may think about removing that in the future. So this is not used right now, but it's in there. And there's also the messaged, which provides logging services, MK Launcher for starting applications, the config server for deploying user interfaces. MK wrapper is basically a wrapper around the MachineKit Linux CNC Python module. So in the future, maybe this might be replaced directly by services implemented inside MachineKit. So it's not a wrapper, but maybe like directly interfaces with Machinetalk MachineKit components. And there is the preview module, which serves as remote interfaces for preview. Let's take a look at an example. This is a diagram. This diagram shows a HAL remote. So we have the HalTalk application or component of MachineKit running on the real-time host. HalTalk itself is a userland application, but it's using the HAL API to interact with the HAL instance, which is running in the real-time environment. And the remote component is purely controlled via this API. So the remote component itself can be connected to any other HAL component, but the updates happen like from the userland thread. So if you have a remote component, it can interact with other real-time components, but the component itself, it's instantiated by the HalTalk daemon or client, yeah. And on the other side, like we have two services implemented by HalTalk, hal-r command, hal-r comp. On the other side, we have the client, let's say maybe a Qt Quick VCP user interface. This implements one remote component or maybe another remote component, and through the two services, it can get status updates via hal-r comp, and it can send status updates itself, like a pin change, for example, via hal-r command. And the layer here, like it could be like a network in between the two applications, like client and host. It could be located on the same computer, and like this is the real beauty actually of Machinetalk, that you can deploy the application everywhere you want without needing some extra work here. So yeah, what about NML? Currently, like actually Machinetalk was designed to replace NML at some point in the future. However, this is currently not completed, and that's also the reason why there's, for example, the NQ wrapper component. So it should serve as an and state like that can be reused in the future, but until the NML has been removed, like it will work with the wrapper, for example. But in order to remove NML, a major refactoring of the CNC stack would be necessary. And at this point, it may be like this is something that has to be discussed. It may be necessary to maybe even rewrite some components, or if we think of a little bit of it, maybe we can make it more like, that the CNC stack is very has parts of it that are more complicated or more specialized than necessary, and it may be good to redesign this in general. And yeah, in this process, it might be possible, like it should be possible to replace NML and all. But again, this would require a lot of refactoring work, and so far the work did not using Machinetalk was now mainly, for example, for user interfaces and so on. And this was also like another reason was we still had to figure out how everything works, and to try to find ways how the communication works and how to set up components and so on. So now that's a lot more mature than let's say 1.5 years ago. And yeah, in the future we may go on and work on this task, but yeah, this still has to be decided how and when this will be approached. Yeah, and you may have seen it on GitHub and maybe also a little bit on a mailing list. Yeah, what is actually Machinetalk GSL? So I was looking into Machinetalk a little bit more and found out yeah, actually Machinetalk is a little bit more than just throwing together Protobuf, CRMQ, DNS SD, and also multicast DNS. It's actually there's a lot of knowledge embedded in the code of the components. Let's say Talk, for example, also knows a lot about how the communication works, how the protocol actually works. And at the same time, Machinetalk, the idea is that you can use it everywhere, in every programming language, in every platform, and so on. The idea was to make it really portable, so everyone who if someone comes along and says, hey, I want a nice web user interface written in JavaScript, then he should be able to do that. And for this purpose, the bindings need to be implemented in many languages. And it turned out when I started to implement PyMachinetalk, after implementing Qt VCP, which is written in C++, turned out that everything is very repetitive, because there's a lot of knowledge that actually can be easily replicated, but it's just another programming language. Yeah, it's different, but still the knowledge itself is the same. And on the other hand, protocols, there are ways to formalize protocols, and it's maybe better to use another model or another way to model that, basically. And another problem was how does Protobuf relate to messages in Machinetalk? Protobuf is good for defining structure and creating a serialization format, basically, but there is no way in it where it can be defined how a message, what a message is. For example, let's say we have a status update from MQWrapper, then we don't know if this is an incremental update or a full update. Yeah, we can define that. But on the other hand, we don't know which fields of the message relate to which Machinetalk message. So a Protobuf defines a structure, but if we don't use all fields, We don't know if this message should, for example, contain this field and which parts of the actual protobuf structure are used. And so I looked a little bit into this and found out, yeah, actually there are other middleware projects which use different approaches to solve this problem, and looked a little bit into it. And at some point I found out that maybe like using modeling to do that, like basically use another programming approach for this part of the software might be a good idea. So when reading the CRMQ guidebook, I found out that they used something called GSL, Generator Scripting Language, internally at Amatics a lot, especially for tasks for building protocols, like basically creating clients and servers that communicate over some kind of protocol. And GSL itself calls itself like something like model-oriented programming. So the idea is that you control both the model of something and at the same time also the generator, the code generator. And if you take a look at this diagram, we have, in the case of GSL, we have an XML model. This can be anything, like just a XML file. And we have GSL template. So this is basically the code generator. This is then used by the GSL interpreter to generate any kind of code. So it could be C++, it could be Python, it could be whatever, it could be even HAL files, for example. I don't know. And yeah, let's look at an example. So this is how a very simple GSL file looks like. You see it is a combination of a templating language and also the real, the real programming code. This, for example, we generate just some class, it generates a class with a few properties in Python, actually. Yeah. And you see it's probably not in the first place, not the easiest to read itself, but you see it's very powerful when it's used for very repetitive tasks. Let's say we would use this also for creating not only a Python class, but also maybe a C++ class or a JavaScript class. We could use the same model to generate O3. And if we take a look at HAL Remote, we see that this was actually already created in the process of creating the models. We see basically that the HAL Remote protocol is using a lot of states. So it's stateless on the server side, but it's stateful on the client. And if we took a look at the clients, we say that it has 2 low-level state machines and 1 top-level state machine. So this is one service, for example, in this case, the HAL rcomp, HAL r command, and they both together work as HAL remote, like the HAL remote component in this case. And we say that this is a lot, like writing this in code is clearly possible, but then the big problem is if we write this in 3 programming languages or the 4th time and whatever, we see we have to repeat it over and over again. And at the same time, like the model is a lot more visual. Like you see that it's a lot more readable than if this would be written inside code. And another feature of like modeling is also that you can verify it with model checking, but that's another, that would be a whole another talk, I think. Yeah. And the way I decided this was I created 3 layers. There is the channel layer where, for example, in this case, we have a subscriber component, and we have an RPC client component. this form together, like this case this is HAL R comp, HAL R command, and these are combined together by a composition layer. This is the remote component base, and then on top of that we have some implementation layer, which basically implements the interface or the abstract class in this case, depending on the programming language, and that does language dependent stuff on top of that. So this is generated, this part of the component, and this part is like implemented. And altogether, it looks like the whole code generation toolchain looks something like this. So we have this Protobuf compiler still in there. This is part of Protobuf basically, which generates language-dependent message classes. And here we have the free model, like two models, sorry. There's a component model, there's a protocol model, and there's one template. They're used together by a code generator to generate the base classes, which are then implemented, like with a language-dependent implementation. Let's say, for example, in Qt Quick VCP, this is the layer where it translates everything for QML, basically. So it translates the protobuf message into like a JSON structure. This is pushed into the user interface, for example. And the base class already uses the message classes from Protobuf, and these together can be used to, like they're just sending out messages or using the Protobuf Machinetalk messages for communication. And yeah, the idea was like to also make the implementation of new Machinetalk language bindings a lot easier, and like a process basically that you can follow. So the first thing you will need to do is to find some libraries. Let's say you have basically need a Protobuf library, you need a CRMQ library, and also some way of service discovery. And this is another nice thing, since we have abstracted away the protocol from and everything from the language binding itself. We can even use, instead of Protobuf, let's say JSON, for example, instead of CRMQ WebTalk, like WebSockets. This is actually used in WebTalk. So there's just a translation component in between, like CRMQ and, for example, WebSockets, and we can use the same process here to also generate the client code, which is uses a complete different technology. Yeah, after finding the libraries, let's say PyZMQ in Python, for example, we have create let's say a minimum viable product, or like a prototype or whatever you might call it, where we just try out how it works, how we communicate basically. And based on that, we can write a code generator. Like already the implemented code generators also help doing this. And after that, if we see if it works, we can create the implementation layer, which is, for example, let's say in the for Machinetalk application status. This is where all the status messages from MachineKit come in. We want to represent this in a nice native, whatever JavaScript structure. Then we would write this in the implementation details. Yeah, and my conclusion about this is it's not up to date. Actually, it's from I think half a year back or so. But GSL is very good for writing protocols in a language independent way, and also in a more formalized way. If you write something more than once, like let's say a MachineKit language binding, it's a lot less repetitive, because you only have to write the code generator and not implement it like 5 times. And it's important actually in this case to focus on good models. So that was something I had to really work on, like finding the right state machine model, and also finding a way to model the protocols and so on. And the most important part, I think, is that you can stay really consistent across languages when it comes to the protocol. So if you find out, oh, okay, we have to change something in the protocol, or we found out, oh, there's a problem. Let's say the bind command has a return message or whatever, to return a new feature that it returns, like, let's say, also more details or whatever, like it returns something different, and we can implement it just in a model, and a just simple update of the code generator, like the generated code, will represent this in every language. So if we find any kind of problem in this, then it's a lot easier to fix, actually. And if we take a look at how efficient actually this is for different programming languages, you see for Python, the code generation ratio, let's call it, is smaller, for example, than in C++, of course. There is also an approach for creating documentation, and also like UPAL, this was a more an academic task, let's say, which I did for my master thesis, which was a formal verification of the models itself. Yeah, what are the applications? It's currently used in Quick VCP. It's also used in Machinetalk, and also in the Web VCP, which is basically something similar to Quick VCP, but with QML Web. Let's call it WebTalk NG, because WebTalk itself was basically inside the machine kit code. It is basically a translator between CRMQ and WebSockets and Protobuf and JSON. And WebVCP uses another, like, also translates between WebSockets and CRMQ, but does not translate Protobuf, for example, because there's already a good Protobuf implementation for client-side JavaScript. So this is also used here. And there is no Machinetalk, but this is currently not used. Like there's a generator for the bindings, but it's not used right now. It's for server-side JavaScript, basically. Yeah, what more? There's also, like, I did formal verification, at least of the basic protocols, like the RPC client and subscribe, publish subscribe. Yeah, this is more an academic task, I think. And there's also currently in there SCXML support, which is a standard for for creating state machines. Which is also a good feature of GSL, is that it works with XML. So this works perfectly fine also with the state chart XML, for example. This is a good feature actually. So can you use Machinetalk also for other applications? Yeah, this is a big question, I think. And yes, basically, it's pretty easy to use for other applications. I've used it already used it in another project where I created basically a new Machinetalk service and component. And the Machinetalk generic patches basically just refactor out like things like project name and so on. So it can change your project name to whatever, my cool Machinetalk or whatever, and then work on top of that. And the nice thing is you can have also multiple Machinetalks inside a single application. So if you have the standard MachineKit Machinetalk and next to that something, your own file service, whatever, then it also works. And yeah, it just adds a project namespace package depending on the programming language. And you can, of course, with Machinetalk GSL, you can generate both client and server base code. You have to do the implementation yourself, but you already have a good structure to start with. How it can be used? Yeah, first of all, you have to fork Machinetalk Protobuf, then fork Machinetalk GSL, then change the project name alias defined in the make files usually, at least for the Protobuf bindings, and for GSL, you just create a new model with the correct namespace. Then you have to implement your protocols. This is done with the in the XML files with the correct format. Then you have to define a message structure in Protobuf. It's, of course, like the Protobuf structure in general of Machinetalk is there's one single container message, and the type is specified inside the container message, and this is basically how it works. So you also have a single container message, and on top of that, you can create your own types and payload or whatever you want. Then you generate the basic bindings, and then you implement the actual code on top of it. Okay, and last but not least, I will go to the current status of Machinetalk. So I've started to I worked on Machinetalk like 1.5 years ago, and there was a long void, I think, in the last year. I'm not sure how many people actually used it, but basically there was a big problem in it that it used the Avahi Python bindings, which itself used the Python dbus API, which is based on the glib bindings, and this is a little bit they work, but they're not very good if you're working with Python threads at the same time. And so the use case of using the Machinetalk actually is, let's say, to create high-level tests for the Machinetalk components inside MachineKit could not be satisfied, because like waiting for the event loop and at the same time do threading did not work out very well. So this was one thing I tried to fix in last month, basically to replace the Avahi bindings with Python zeroconf, which is also like a multicast DNS, DNSSD implementation, but written purely in Python without using Avahi. And also I used, of course, the Machinetalk GSL stuff. So I replaced the core, which was implemented by hand with the GSL generated code. And if you take a look at in the GitHub repository, you see that it's now a lot easier to read and everything, because like the complicated stuff is is basically inside the generated code. So all the logic, like state machines and so on, is in a generated code, and the rest of it is just representation in Python, basically. It implements a similar interface to the MachineKit HAL bindings. And now I've added it also to PyPy, so you can install it with via pip. And since it's not using Avahi, you can basically use it and install it on anything that works, like any platform that uses Python, not only Linux. Although I have not tried it yet, so if you find problems on Windows or Mac, then just create an issue and GitHub. And let's take a look at an example. There's also I've added a new, easier to use service discovery API. You just so basically you import the Machinetalk and the service discovery part of Machinetalk. Then you create the service discovery component. Here you can also specify like filters, like example using a special UUID, and then create a component like you would create it in, like, let's say if you write a new HAL component in Python, then you would do it like in a similar way. Then you just register it with service discovery. Then you say service discovery start, and then you can use a simple loop basically to, like, let's say, print out status messages, update the component, and so on. So it's pretty similar to writing a HAL Python component. And that's the whole idea, like that it's also easy to use and pretty similar to use to the standard HAL components, basically. Okay, now I've come to the end of my presentations. Are there any questions? I think we have to use this.
Oh.
Maybe.
Glad to see you're using Protobuf. I ran across a new thing last week, designed by the same guy who implemented Protobuf version 2 for Google, called, I think it's called Captain Proto.
Yeah.
And it's supposed to be lower overhead because you don't have to pack and unpack messages. And also if you have like two messages where the result of the first one is used as a parameter for the second one, it can actually fold those into less messages overall, so it's faster. Are you familiar with that? Do you think that? And it has bindings for like all the same languages too.
I've seen that, but I've not looked too much into this. Yeah, the RPC feature would be pretty cool because that's something that's missing in Protobuf at all. But that's now also something that's done in the model itself, like the representation of the whole RPC, for example.
Thanks.
Any other questions?
I really like the GSL part. I think I could apply that to some other projects.
Maybe can someone look if there are questions on the Hangouts? Okay. Okay, then thank you very much for your attention, and